All right, welcome back, class. This will be the Unit 7 test review video. So this will go along with the notes in class if you want some extra review. So in this first one, we will be graphing a circle, and they'll be ordered in the way that we learned them. So it'll go circles, ellipses, hyperbola, parabola. So it'll look familiar. In this first one, the center, remember HK is with XY, so then it's going to be 2, -1. So 2, -1, and a radius, well, this is set equal to r squared. So when we take the square root, the radius is going to be 3. And I like to go up, down, left, and right because that will make the most accurate distance away for 3 units. This next one, we have then writing of an equation. So the standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared. The center, that's our hk. And then the point here, that's our xy. So we can plug in hk first. You could do either way, but I think this is the better of the two options. So then we have x minus 3 squared plus y. It'd be minus a -4, so plus 4 squared equals r squared. Next, we can plug in 1 -3. So then we have 1 minus 3 squared plus, well, now it would be a -3 plus 4 squared equals r squared. So we can simplify to solve for r squared. So then we have, this would be -2 squared plus, well, this would be 1 squared equals r squared. So then we have 4 plus 1 equals r squared, so 5 equals r squared. At this point, we're not done. This is not the final solution. We need to plug this back into this step in green, because now we have our xy with the actual point. So that's why I like to do that step first. So then when we rewrite it, it's going to be x minus 3 squared plus y plus 4 squared equals 5 when we plug in for r squared. So now this would be our final answer. So since we're going in order, next we'll have ellipses. In this case, remember, we are looking for the bigger of the two for our a squared. But first, I'm going to look at the center. The center is for our hk still. So when we have h with x and k with y, our center is going to be opposite. So -4 and -5 here is our center. So we can plot that. I might scale it by 2s. I can't tell as of right now if it's going to be too big, but this way I'll be sure that it'll fit on the graph. So if we go by 2s, -4, 2, 4, 5 would be right there. The vertices, since x is with the bigger of the two values, so 36, it's going to be horizontal. Our vertices are with the bigger of the two for the denominator. So now that we know that, we can label it as horizontal. A squared is 36, so then A is 6. B squared is 16, so B would be 4. A goes with the way that it will be. Since it's horizontal, A will move left and right from the center, 6 units, so 2, 4, 6, 2, 4, 6. These are our vertices. Those points then will be plus or minus 6 from -4. So -4 minus 6 would be -10, -5. And then our other point would be plus 6, so we'd have 2, -5. And you can see those points on the graph as well. Now from the center, for our co-vertices, we're going to go plus or minus 4 vertically. So 2, 4, 2, 4. These are our co-vertices. Now we can draw our ellipse. That one's okay. And then again, those points now are plus or minus 4 from our y value. So we're going to have negative 4, and then negative 5 minus 4 would be negative 9, and then negative 5 plus 4 would be negative 1. So then those would be our covertices. Since the standard form here for the ellipse is going to be plus, the foci is the opposite for the equation. It'll be a squared minus b squared equals c squared. So we can plug in our a squared and b squared. So then we get 36 minus 16 equals c squared. So then we have 20 equals c squared. So c equals square roots of 20. Let's see if we can factor that to break it down. So then we have 4 times 5, and we have 2 times 2. So we have 2 factors of 2, so we can pull that out. So then we have 2 square roots of 5. On the graph, we're going to move left and right 2 square roots of 5 from the center. So that's going to be in between 4 and 5. So 2, 4 will be right about here and here for our foci. When we write those points, we're going to want to use this reduced form. So from the center, we're moving left and right. So the x value is going to move. So it's going to be negative 4 plus 2 square roots of 5, negative 5, and then negative 4 minus 2 square roots of 5, negative 5. These two are our focus points, and those will be the exact points on the graph. So, hint, make a sketch. You, at this point, should hopefully realize I like to make the sketch. I think that makes it easier to then visualize. So I like to do the vertices first. So we have 5, 2, 1, 2, 3, 4, 5, 1, 2. That's a vertice. And then 5, negative 6, 1, 2, 3, 4, 5, 6. From here, we don't know what the center is, but the total distance between the two is 2a. Because from wherever the center is to a vertice is a, so if we double that, it'd be 2a from vertice to vertice. You can count to see what that distance is, or you can just see that it's going to shift from 2 to negative 6 here. So let's see. Oops. Oh, I made a mistake. It's going to be 5 over and then down negative 6. So 1, 2, 3, 4, 5, 6. Down like this, because our x value stays the same. So now from this vertice to that vertice, it's going to be a total of 8 units. So then a is 4, so a squared is 16. That's one piece of information we need. Since we know what a is, we can see that from either vertice, the center is going to be 4 units away. So if we go 1, 2, 3, 4, this will be the center. So the center is going to be plus or minus 4 from the vertices. So if we go minus 4 from this one, so it'd be 2 minus 4, it'd be 5, negative 2. So that's our HK now. So we have our HK, we have A squared, we still need B squared. The foci is going to be at 5, 1 and 5, negative 5. So you could do that total distance from focus to focus as 2c, or now that we have the center, you could do focus to center. So this distance is going to be c. And it looks like that distance is going to be 3. 1, 2, 3 is what I get. So c equals 3. So c squared equals 9. So now we can use that equation. So we have a squared minus b squared equals c squared. So we're solving for b squared. So we get negative 5, or excuse me, that should be negative 7. Because negative 7 minus 9 would be negative 16. So then if we divide by negative 1, we get b squared equals 7. Now we can write the standard form. Since the vertices and foci are vertical, it's going to be a vertical standard form of the equation. So that was when then a squared is under y squared. So we have x minus h squared over b squared plus y minus k squared over a squared equals 1. We can plug in those values we found. So we have x minus 5 squared over 7 plus y minus a negative 2, so plus 2 squared over 16 equals 1. All right. Next, we have the graphing then for a hyperbola. So it's always going to be set equal to 1, so we need to divide both sides by 16 to get it in that form. So we divide everything by 16. I'm going to rewrite it up here. So then we have x minus 2 squared over 16 minus 4 over 16 will reduce to 1 over 4. So minus y plus 3 squared over 4 equals 16 over 16 would just simplify to 1. Now we want to find the center. So again, HK is with x and y. So we have an h and a k. So our center is going to be 2, negative 3. So 2, negative 3 is right there. In this case, a squared is not the bigger of the two values, but in this situation it will be. A squared with hyperbola is going to lead. So just because this one is bigger than 4, that doesn't mean that'll always be the case with hyperbola. So this is a squared, so then a is 4. Since x comes first, it's going to open left and right. So 4 units from the center, left and right. 1, 2, 3, 4. 1, 2, 3, 4. B squared, so b is 2. Those aren't actual co-vertices, but this will help us draw the box, knowing how tall it will be then. But first, let's find out what the vertices were. It looks like negative 2, negative 3. And then if we add 4, it'll be 6, negative 3. We can then plot these points plus or minus 2. And now we can draw that box to see where those asymptotes will go through. So through the center and then through the diagonals is how those will look. I like to do the slope next. So our slope is going to be plus 2 over 4 and minus 2 over 4 for the rise and run. So plus and minus 2 over 4, which we can simplify to plus or minus half. And then for the standard form, it's y minus y1 equals m at times x minus x1. Our y1, x1 is a point that both of these lines go through. They both go through the center, so the point we're going to use is the center. So y minus, it'd be negative 3, because this is our y1, so y plus 3 equals plus or minus half, and then we have x minus 2. So this would be the standard form for the asymptotes. Now for our foci, since it was minus, our equation is going to be a squared plus b squared equals c squared. So then we have 16 plus 4 equals c squared, so 20 equals c squared. So C equals square roots of 20. We solved square roots of 20 earlier, and that was 2 square roots of 5. And it opens left and right, so then it's 2 square roots of 5 left and right from the center. So that's just greater than 4, so that'll be there and there. Now we can draw our branches of the hyperbola from our vertices. And then the focus points, since it's from the center, it's moving left and right, it's going to be 2 plus 2 square roots of 5, negative 3, and then 2 minus 2 square roots of 5, negative 3. These 2 points are the focus points. Writing the equation of a hyperbola, again, hint, make a sketch. This will help you see what the graph looks like, and then if it opens left or right or up or down. The vertices are 4, negative 5, so 1, 2, 3, 4, 1, 2, 3, 4, 5. Vertice, excuse me, and then up, over 4, up 5, 1, 2, 3, 4, 5. Vertice. Just like with the ellipse, that total distance from vertice to vertice is going to be 2a. So 2a, so I'm going to do that down here. 2a equals, that total distance then is going to be 5 and then plus another 5. So 2a equals 10. So then a equals 5. So a squared equals 25. So we have an a squared, again, just like with the ellipse, we have a. So from a vertice to the center is a. Since they're both 5 away from the x-axis, the center is going to be on the x-axis. So then the center is going to be at 4, 0. So that's our HK. Now, since we know the center is at 0 for the y value, and we go for the focus point plus or minus 3 square roots of 5, so we go 3 square roots of 5 up and 3 square roots of 5 down. That means that that has to be C because we started at 0 and added those values. So either one of these could be C. So since we know C is 3 square roots of 5, we can solve then for C squared. So 3 square roots of 5 squared. So when we distribute that squared through, we get 9. When we square the square root, it simplifies, so we have 9 times 5, so 45. So now we have our C squared. So now we can use that equation. So since the standard form of the equation for a hyperbola is minus, it's going to be plus, so 25 plus b squared equals 45. So minus 25 from both sides. B squared will then be 20. All right, now we have a squared, b squared in our HK. The vertices are up and down. So since they're up and down, it opens up, down. So now we have, in this case, the a squared comes first, so we're going to want the way it opens to come first. Since it's up, down, it's going to lead with y squared over a squared minus x minus h squared over b squared equals 1. So we can plug those values in. So we have y minus 0, because our center was at 4, 0, over 25 minus x minus 4 squared over 20 equals 1. All right, I think we have 2 more here. So graphing of now the parabola. To see which way it opens, we want to know what comes first and if it's positive. So x equals and it's positive. So we want positive values for x. So that means it's going to open to the right. Also, for our HK, there is no h here because it's like plus 0. And our k is 2. So it's going to be 0, negative 2. That's our vertex. To find the focus, we need to set this fraction 1 over 12 equal to 1 over 4p. So then we have 4p equals 12. So divide both sides by 4. So p equals 3. P will help us find the focus and the directrix. Since it opens right, that means the focus is going to be to the right 3 units because it's p units away. So 1, 2, 3 is our focus. And then the directrix is going to be 3 units outside of, so to the left. And this is the line 1, 2, 3. So that focus point looks like 3, -2. And then the directrix, it's always the same. If it's an x equals, then the directrix is going to be x equals. And it's -3 because it was 3 units back. Now we need to know some points that a parabola is going to go through. So the total distance from focus to directrix is doubled p. So if we notice p is 3, then we need to go 6 units away, up and down. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now we can see it's decently wide, and that's what our parabola is going to look like. Finally, we have a writing of the equation of the parabola, and they give us a vertex. The vertex is our HK, and then the directrix. So again, drawing that graph will help. So -2, 1 is a vertex. The directrix is at x equals -5. So we're back 2, so 3, 4, 5. This is the directrix, which is the line. So again, in this case, since the directrix is left of the vertex, it's going to open to the right. So opens right. So then that standard form is going to be x minus h equals a positive, because it'll be positive values for x, 1 over 4p y minus k squared. We have an hk. We need to find p. Well, the distance from the vertex to the directrix is p. So that's 1, 2, 3 units, it looks like. So this distance is p, which is 3. So now we have h, k, and p, so we can plug those in. So we have x minus a -2, so that could be written as plus. And then 1 over 4 times 3, since that's p. And then y minus 1 squared. We can simplify, so that's x plus 2, 1 over 4 times 3 is 12, y minus 1 squared. This would be the standard form of this parabola. All right, that'll be all the review